Hello and welcome, this is Matthew. And I know, it's been a very long time since I last uploaded a video. Now I'll explain why in a second. But, for today's idea, I decided to make an advent calendar of integrals. Now I got this idea from Flammable Maths, and I will link his channel down below. So for the next 24 days of December, I will be posting a new integral video. So, yeah. But back to why I haven't uploaded in a while. Well, because I've been busy with college and all of that stuff. And in that time that I've been gone, in the month and a half that I've been gone, I've also had a birthday. I am now 14 years old. I turned 14 on November 1st, and I have, like I said, been busy with my college. I will be getting my bachelor's degree at 15 and a half. Now, yeah, that's why I haven't uploaded in a while. Okay, so we should start with a easier integral. So every day the integrals will get slightly harder, in my opinion. So let's start off with a easier, well-known integral, the Dirichlet integral. So I is equal to the integral from 0 to infinity of sine of x over x dx. Okay, now usually you'll see on YouTube people will use Feynman's trick, but I don't really want to use Feynman's trick today. Now, I love Feynman's trick more than probably anybody, but let's do it a bit differently. The way I want to do it is, we know that 1 over x is equal to the integral from 0 to infinity of e to the negative tx dt. Now, this is literally just the Laplace transform of 1 transforming into x. Now, this integral is very easy to evaluate to show that this is true, so let's go ahead and apply this to our integral. So now we have I is the double integral, and both integrals are from 0 to infinity. Okay. And our integrand is sine of x times e to the negative tx dt dx. Okay. Now we have to ask a question. Can we integrate with respect to x first instead of t? Well, the answer is yes, because our function of two variables, f of t comma x, is in fact continuous over our bounds. So, therefore, we can integrate with respect to x first and then t. There we go. Now, I want to make use of another fact. Well, what fact do I want to make use of? Well, e to the I x is equal to cosine of x plus I sine of x, where I is just our imaginary unit. And if we take the imaginary part of both sides, imaginary part of e to the I x, this is then just sine of x. Okay, so let's apply this to our integral I. We now have I is the imaginary part of the double integral, both from 0 to infinity. And we'll have a e to the negative x times t minus I. There we go. Okay. Now, this integral is pretty straightforward. I'm talking about the inner integral, of course. This is a very straightforward integral. I will leave that as a sort of homework for you. But we should now have our integral is equal to the imaginary part of the integral from 0 to infinity of e to the negative x times t minus I over negative t minus I from 0 to infinity, and then of course dt. Now if we evaluate the inside, we'll then just have 1 over t minus I. So our first inner integral, or the only inner integral, is just going to evaluate to 1 over t minus I. Okay, now we want to bring in the imaginary part. So imaginary part inside, and we'll just take the imaginary part of our integrand. Well, to do that, we'll multiply the numerator and denominator by our complex conjugate, so t plus I, t plus I. And in the denominator, we'll just have t squared plus 1, of course. And then the imaginary part of this function will then just be equal to 1 divided by t squared plus 1 dt. Now we have I is equal to the integral from 0 to infinity of 1 divided by t squared plus 1 dt. Now this integral is also pretty straightforward. It's equal to arctangent of t evaluated from 0 to infinity, which is then just going to be the limit as t goes to infinity of arctangent of t. There we go. And then minus 0, because arctangent of 0 is just 0. And now this is also just pi over 2, because the limit as t goes to infinity of arctangent of t is just going to be pi over 2. Okay, so that means I is equal to pi over 2. So let me go write this down and we'll be finished with this episode. Here we are. Now, before we end this video, I'd like to say one more thing. Since our integrand, sine of x over x, is an even function, that implies that the integral from negative infinity to positive infinity of sine of x over x is then just going to be twice the integral from 0 to infinity of sine of x over x dx, which is then just going to be equal to pi. So, now this is true because we're just using symmetry in this case. Okay, well, that concludes our first episode of the series. I hope you enjoyed this video, and have a good day.